Hi, everyone. I'm Nihali. I'm a cloud solution architect at Microsoft. Welcome to the Art of the Possible series. This part of the series is focused on AKS networking. Today, we have a special guest, Amit Gupta from our ISV partner, Isovalent, who's going to walk us through the BYO scenario, BYO CNI scenario. And we also have architects and colleagues from cross-functional teams providing diverse perspective to support this initiative. So thank you everyone for joining. LinkedIn profile for all of the architects and Amit is below. So to set the stage and for the continuity of this series, I'll take a 2-minute rundown of what we've done so far. So in the previous videos, we set the stage. We started with what I call Docker networking. So we had a 2-host cluster, and then we created a Docker Swarm cluster. And we talked about overlay networking. We talked about VXLAN. We did a few packet captures. We showed how overlay networking works, inner packet, outer packet. So be sure to check out those initial video. It lays the foundation for some of the complex concepts and overlays that we're going to cover today. And then next we looked at AKS networking. We looked at the let's start with, we started with what we call the KubeNet, which is now referred to as a legacy CNI. But in KubeNet, we noted that the pod network and the node network are different. And the use case for that is IP address conservation. Right. So in this option, you get a lot of IPs for the pod. The downside of that is that we needed UDRs to route the traffic back. Then we looked at the more common CNI, which is the overlay, CNI overlay AKS, Azure CNI overlay, which lays the foundation for the newer way of doing it. And this is our go forward CNI, and it looks very similar to KubeNet. It also does IP address conservation, but of course, no UDRs are required for this, and it uses overlay network under the hood. And then we did dual stack, as you saw in the previous video, so be sure to check that out. And so that lays the foundation for today's topic, which is BYO's scenario, right? So with BYO, what happens is we deploy a cluster without a network plugin. So it looks something like this. Let me just zoom in a little bit. So you deploy the cluster without the network plugin. You have 3-node AKS cluster. And when you look at the node, you will see that the nodes are not ready. So this is where I hand this over to Amit to walk us through BYO scenario. And Amit, thank you again for joining us. Please introduce yourself and take it away.
Yeah, thank you so much, Nihali, and hello, everyone. My name is Amit Gupta. I'm a senior technical marketing engineer at Isovalent, and been working with the AKS team for quite some time for sort of, making sure that Cilium sort of works across different sort of scenarios within the AKS portfolio as well as the Azure portfolio. I'll walk you through some of the things for Bring Your Own CNI as well as another offering which is called as Isovalent Enterprise for Cilium from the Azure Marketplace. Let me just share my screen real quick. And let me know if you can see my screen.
Excellent. Yeah, it's loading. Yeah, we can see it now.
Yeah, so the way I'm gonna break this up is to the fact that I'm going to walk you through from the perspective of what Cilium brings from a perspective of a CNI in the Azure portfolio, along with 2 offers, which is Bring Your Own CNI and Isovalent Enterprise for Cilium, Isovalent Enterprise for Cilium, as well as the fact that I have a couple of short demos that I want to show to you, like how those particular features from an enterprise perspective look like. Feel free to ask questions. I'm here to answer your questions, make things more clearer. I'm also going to sort of, in the background, do the creation of these clusters and Bring Your Own CNI, as well as an Isovalent Enterprise for Cilium using Terraform. So that's also something I will introduce to you and as well as the broader team as to the fact that that is something which is available and you can sort of use that as well. Well, I mean, long story short, Isovalent sort of was founded by the creators of eBPF and Cilium, which is Thomas Graf and Dan Van Nguyen. So we are now a part of Cisco. So we've sort of gone ahead and sort of merged into a group called the Security Business Group, wherein we are trying to do some more things around the networking, security, and the observability portfolio. I don't want to go more deeper into the classical stuff that we talk with, from a customer on that perspective. But these are some four particular verticals that keep changing from an enterprise perspective: security, reliability, observability, performance, and scalability. These are all something which we all look at from the perspective that the network is fundamental to achieving them. Like I said, I mean, it started off with traditional IT, virtualization, Kubernetes, and multi-cloud is picked up, and that's where Linux or eBPF comes into the picture. Cilium is the newer standard. And I'll just break away. So Cilium is a breakthrough CNI wherein you do things from the perspective of not just going across and doing it the classical way of IP tables, but we use something called as an extended Berkeley packet filter. You're doing things runtime in the kernel itself, thereby expediting the packet forwarding and sort of making sure that you're not sort of getting blocked with something which is designed years ago from the perspective of IP tables. So this is all, when you look at the kind of feature set of persona that you were looking at from just a CNI, it's just not a CNI which you are just going to do from a networking perspective, but you have multiple other feature sets that also open up. You have the load balancing, ingress, service mesh, cluster meshing. You want to talk across clusters. You want to make sure that workloads can talk across clouds from bare metal to Azure Arc, all of those things come in network security. You're looking at layer 3, layer 4, layer 7 DNS-based policies. You're also looking at runtime security and observability. And something very cool, which we call as Hubble as well as Tetragon, that I will also showcase in this particular walkthrough. Starting off, so this is how the journey has been. 2021, the eBPF Foundation was announced. 2022, we sort of partnered with the Azure team for something called as Azure CNI powered by Cilium, wherein the control plane comes in from AKS, but the data plane comes in from, which is the eBPF based high performance data plane, comes in from the Isovalent team. 2023, Azure CNI powered by Cilium goes GA. It was available in both modes, overlay as well as VNet. 2023, that's where we come into the picture. We launched Isovalent Enterprise, which is available via the marketplace. You can either do a one-click install and upgrade, meaning a greenfield, as well as a brownfield sort of an installation. And multiple scenarios are supported. You want to move from KubeNet, you want to move from Azure CNI overlay, you want to move from something which is Azure CNI powered by Cilium. You can just do a one-click upgrade and you can do it. You can also use easy CLI, ARM templates, Terraform, even Bicep. 2024, we partnered with the Azure Linux team. We are a trusted partner. We validated multiple scenarios for them, as well as for Azure Arc. We've added support for Azure Arc as well. Like I said, what is Cilium? If you look at it from a very simplistic perspective, right? It works in the concept where you have a Cilium agent, a client, and a CNI plugin, which will be running on every node. So Cilium will go across and compile something called as a BPF program that makes the kernel run these programs at specific points that you want to have visibility and control. So you're not going to run it across everything. So in that sense, your packet processing, everything is very richly conserved. You are going to interact with the Linux kernel to install that specific program, which then performs those particular tasks and implements multiple kind of rules, be it security rules or whatever you want. This is how the Cilium data path would look like. And I'm going a little bit just to give a brief idea here. So Cilium data path, it uses something called as eBPF hooks and to load those particular programs. So you'll see a lot of this in this conversation a lot. Like if you create a particular cluster, and I will go about that, you bring your own CNI based cluster, right? And then you install Cilium on top of it. Then what happens is on that particular node, you will see some specific interfaces like Cilium_net, Cilium_host. And I will talk about what happens if you do Cilium_VXLAN versus Cilium_Geneve, or you want to do the native direct routing, which is to use the cloud providers routing, like overlay routing from Azure. Yeah, this is there's a big question from the perspective of which networking model to use. So there are and this is where it branches out, wherein the fact that do you want to use something like a encapsulation type, which is like a VXLAN or Genie, that's where bring your own CNI comes into the picture. Because you are not sort of, the user is not sort of going across and saying that I would like to use something from, I want to use something very exclusive than what the cloud provider is providing. Let's say Azure is providing overlay. I don't want to use that. I want to use VXLAN or Genie. Vis-a-vis the other side of the portfolio, which is direct native routing mode, wherein it's going to be looked up. You're going to look up to the cloud provider. How does he handle those particular packets? We will just route those packets as like a local process, and we will just start emitting those packets out to that particular scenario. And that is where I will talk about something we use from the Azure side, which is called as a delegated IPAM to give us those particular rules to go across and install. But this is where the bifurcation happens. On the left side, you have something called as overlay network, which is where bring your own CNI comes in. On the right hand side is where you have Isovalent Enterprise or Cilium from the marketplace. On both sides, you are going to work on the enterprise perspective of using Isovalent as sort of running on top of it as the software, where Cilium runs as the CNI. So if you look at it from a packet flow perspective, right? Let's say this is about VXLAN. So let me just take it here. So you have a pod one. So let's assume there are two nodes here, right? And this is a pod here. This is a pod here, and it wants to communicate. It attaches, and I will show in that example as well. Like you have a LXC interface that gets created. This guy's default gateway is nothing but is corresponding to the Cilium host IP. So it's going to send that packet across to Cilium VXLAN. It's going to send it here. I mean, these are some top of the rack switches or routers. It's going to this particular interface. So here it's getting encapsulated. Here it's getting decapsulated, sent to the LXC interface, and that sends it to that particular pod. Visive is something that you are looking at it from a direct routing mode. Now here you have a routing daemon which is running. You can have like a free flow of L2 layer 3, or like even if you want to run BGP, we support BGP as well. So if you want to run BGP, you can go across and propagate those routes, to those TORs, and those TORs can communicate, those TORs can send it here, and then the communication can happen via this mechanisms. With that, I will go across and talk about, what is bring your own CNI. Bring your own CNI is a concept wherein you do not want to use the network plugin functionality from a particular cloud provider, in this case, AKS. So you go across and sort of, basically create a cluster. When you create the cluster, there is no CNI running. The only pods will be core DNS. Then from an AKS perspective, it will be metric, the connectivity pods, and Azure CNS pods. Sorry, not the other, and the connectivity part. So once the CNI is installed on top of it via Helm, or we have something called as a Cilium CLI, you can go across and then install that particular CNI. The nodes come up, and then you can start scheduling apps and whatever you want to do across it. The catch is that if you are going to sort of look at it from an enterprise perspective, there's no support from the Microsoft team for it, because it's not something which is exclusively owned by Microsoft, because it's not running through the fabric of Microsoft. This is something that the incumbent customer / user is sort of trying to do. If you look at the way it's created, like, and I'll show you everything related to that as well. So basically, you have the IPAM mode as cluster pool. You're looking at the VXLAN encapsulation. And it's just a very basic thing that you create the cluster with like network plugin none. This is where the second part comes in, Isovalent Enterprise for Cilium. So you are looking at a gamut of features from an enterprise perspective. By the way, this, like I said, this is also available on the BYO CNI model with the enterprise offering that we have. But just to expand on those use cases, you have like service mesh, you have, like I said, cluster mesh, encryption you want to do, pod to pod, node to node, you want to use WireGuard, you want to use IPsec, you want observability, you want to export your logs to a seam like a Splunk or whatever you want to do. You have network policy, L3, L4, L7, and DNS. Everything is possible. Yeah, this is exactly what I just talked about. And just from a very simplistic perspective, right? Let's say there's a particular customer, he comes across and says, I want to purchase your application. It sends it across to the it pulls the specific definitions, it installs in the cluster. The cluster will then generate something like a API call that happens towards us. Is Isovalent, we'll go across and, we'll work on the metadata and the help charts. We'll package it via CNAP tool, which is a Microsoft tool. We will go across and publish it, push it into the private ACR, and then we are good to go. The customer can then go across and use it. From a high-level architecture for this particular mechanism, it's pretty simplistic. AKS control plane, you provide the, like I said, you have something called as an IPAM delegator, which is something we are using from Azure. So you have the CNS that manages all this particular IP allocation and everything. There is a CRD called as network node config, in short NNC, that goes across and takes care of the fact that either you're in overlay mode or you're in VNet mode or pod subnet mode. That way the subnet delegation happens, or I should say prefix delegation happens. We as the CNI, we will invoke the IPAM to get pod IPs and configure the data path for those particular pods, because that's our job. And this is exactly what I was just talking. So this is the Azure delegated IPAM. We go across and talk to it, fetch that particular information, make sure those IPs are programmed on the Azure network stack before giving out IPs to the Cilium CNI. And this is, like I said, this is the network node config, or something we call as the NNC CRD, which is coming from the Azure side. This is exactly what I was just mentioning. If you look at, on the left side, you have the VNet mode, on the right side, you have the overlay mode, and this is how the NNC or the NNC CRD would look like. How do you install and, go across and go about doing it? You can install Isovalent Enterprise for Cilium from the marketplace using the portal via the ARM templates. There's Azure CLI, there is Terraform, there is Bicep support as well. So you can use any of those mechanisms to go. Any questions? I'm happy to take on questions and then go across.
So thank you, Amit. I think Samyan, I know you had a couple questions.
Sure.
I think this might be a good time to ask as well. And just real quick, Amit, this content's really good. Is this available publicly somewhere, or we could get a PDF as well for this?
I can go across and sort of, compile this into a PDF and send it across.
Sure, excellent. Yeah, go ahead,
Because
Samyan.
a
I
lot
know
of this info was spread across multiple places. I've just tried to make sure that I can collate it together and then get going.
Awesome. Yeah, perfect.
Right. Thanks, Amit. Thanks, Nihali. Amit, my question is related to any specific best practice or a guidance for running like a very large clusters. Like, for example, if you're running a large language model training in AKS, which might need like hundreds or thousands of nodes plus GPU to GPU communication between the nodes, which are running, the workload is going to run in the pods. So if you do that kind of workload which need like a low latency communication, are there any specific considerations or configurations that we need to be aware of with Cilium?
Oh yeah, for sure. So that's a great question. So if you look at, let me just roll back a little bit, and I won't go across these slides again. Bear with me. I just want to sort of show it to you. So if you look at, something like this, right? So basically what like you said, for low latency applications, right? So classically you would run in something called as a IP tables mode. Basically what happens is that your kernel should be able to process those particular packets either via the BPF program or by IP tables. Now, what happens is we have a mode which is called as native routing / BPF host routing. For such low latency kind of applications, right, you can have multiple other options, and like you want to use an RDMA or an InfiniBand kind of a connector, right? We happily work with that. We have no issues. We have something called as AF-XTP, which is, the express data path forwarding, wherein you can go across and use a chipset, which is like, let's say a Mellanox MLX4 or MLX5, which is something that Azure team, the container team, is implementing to use from Cilium's perspective. So what it does is two things. Basically, using that chipset, and like you said about GPU workloads, right? That forwarding, and since you're using something like an RSS or a GRO in the backend from the NIC perspective, right? Cilium packs along with that, and then you get that particular raw power or the low latency that you would want to offer to your particular applications. So all of that is possible. It is totally oblivious to the user. The user doesn't have to do anything fancy. It's all about how you want to, go across and package your cluster for that particular application.
Okay, great. Thanks, Amit. And for that, is there any default monitoring available? Let's say if I need to look into this communication latency or anything. I saw that
Oh,
recently
absolutely.
AKS. Okay, is it
Absolutely.
Retina?
Yeah, so Retina is actually an offshoot of a product that we've had for last 8 years. It's called Hubble. I want to show that as well in this particular demo. I'm going to stop at these slides because these slides tend to, sort of take you into a different domain. I want to go across into the basics of how things work from that perspective. Would that be okay?
Yep. Thank you.
Sure. I will stop the slides here, and this is where it stops. I mean, so just to give a very brief idea, right? So overlay mode, VNet mode is something that is known to your entire team. You're looking at how you want to look at the addressing mechanism that's just being carried forward to from our perspective as well. We are just utilizing what is being given from a control plane perspective by the Azure team. The only catch is that when you're creating these clusters, you're using something called as a network data plane, Cilium, in both scenarios. That's the only thing that you're doing. When a cluster comes up, right? So like I said, if you saw that particular slide where I was showing that the customer is requesting something, right? You need a billing operator. So that's exactly what happens. There is a namespace, which is Azure Extensions usage system, and the billing operator gets created in that. And all of this, gets created on the fly the moment you go across and create or upgrade those clusters. Like I said, we have this support. And as I say that, I will just take a stop here, pause here, and I will just show something very quickly. So this is a repo that I maintain, which talks about all you want to do from every perspective of a CNI combination that's possible with Cilium. It also has a couple of other things like for Calico as well as for the Azure plugin, but multiple scenarios. So what I will do is I will just quickly create a cluster on Bring Your Own CNI on the left side. On the right hand side, it's with Isovalent Enterprise for Cilium. And then we will go across to my bad. Yeah. And if you see here, this is with just checking a couple of things. This should look good as well. Oops. This should ask me a question, which is perfect. So basically what is happening is on the right hand side, if you see, right, so it's an extension. So basically it's an AKS cluster that will get created, and there will be an extension that will be installed on top of it. So that's where it's asking me these questions. I mean, these are variables that I've defined in my variables.tf. So last but not least is so on the left-hand side, that particular cluster will be created like Nihali was showing in the first go with nothing, with just a bare bone AKS cluster with no container networking interface. On the right-hand side, you will see a cluster that will come up completely with Isovalent Enterprise Receiving from the Azure Marketplace. The one on the right-hand side will roughly take about 10 to 11 minutes, and the one left, I think, should take about 2 or 3 minutes. But we will not wait for that. Let that keep going. In the meantime, I will walk you across what I was just talking. So here what I've done is I have an AKS cluster, which is running BYOCNI. Let me just, so let's just quickly look at this and I'll just show you, yeah. Oops, what has happened is I've installed Cilium on top of it. So Cilium is the CNI on this particular Bring Your Own CNI cluster. Now, breaking down into, like, I think Nehali had requested that we could talk about how the communication and all happens, right? So let's just take a very quick look, right? So I have a pod running here, which is, it's a simple Nginx pod. So let's just go. Yeah. If you look at a couple of things on this pod, right? Let's just do an IPA. You have an ETH0 IF22 interface, and let's do an ARP that corresponds to 32.4a something, right? And then you have, and I want to show about the fact that what is actually happening in the perspective of what we talked in the slides. Yeah, by the way, I wanted to show one more thing, that if you see here, right, where is that pod? Yeah, the pod is latched onto VMSS 008. That's exactly the same pod that I'm actually logging into. And I'll go step by step. Anywhere you want to ask questions, please feel free to ask those questions. Let's just do a very simple, just one second. Now, what has happened is that this particular cluster is with the encapsulation type as VXLAN. Like I said, so if you see the stitching of the path, right? So you have an ETH0 IF22 interface, which is going to be, and we saw the ARP here, right? It is 32.4a. If you look for something for 32.4a, right? That is right here. So if you see the mapping, right? So an IF21 interface, LXC interface with IF21 gets mapped to ETH0 IF22. So basically, when the pod will sort of send a request, right, the ARP reply comes back from that LXC interface. So, and if I see the route, right, it is 10.0.0.218. If you quickly look here, right, if you see, so that's nothing but your Cilium underscore host IP. So the default gateway is that. So this is what's, what we're sort of achieving from that particular perspective. With that, let me just go across and create some information for you guys. So what we'll do is we'll create specific pods, and we'll see how layer 3, layer 4 policies, layer 7, and FQDN based policies work from that perspective. So I'll just create something here. Let's just see if these, oops. Yeah, this is fine. So these are getting created. Okay, perfect. These have been now being created. So what's happening is, so I'll just quickly go back into that monitor screen. So you have something called as a Death Star. You have a TIE Fighter, an X-Wing. So what I'm trying to do is, I will send traffic. So right now there is no policy or nothing. So from an X-Wing, I'm trying to send a packet towards Death Star with that particular URL. So that will say something like a ship landed or something. I think coming back to your question, wherein you were asking, how is this something that we can observe, right? So let me just go here and so if you see here, right? So let me just stop at this request, right? So and make this a little bit bigger. So you just saw it that Xping sent a particular information across that was forwarded, the verdict was forwarded. And you see from a perspective of, like I said about Cilium, right? You're not looking at something like the 5-bit tuple. You're looking at a concept of identities. You have a source identity, you have a destination identity. So that's what's getting mapped. So you have all this rich information that you can look at. You have labels from a Kubernetes perspective, the request method, whatever you want to do. And it's just not this. If you want to go across and export this information out, right, to a seam or whatever you want to do, you can do that as well. And let me just go across and do one more thing. Let's just create I'll create an L7 policy. The L7 policy, it's actually a combination of layer 3, layer 4, layer 7. But what it's saying is that actually, let me just do this. Let me create a DNS-based policy first. I think there'll be no change because the pod is already, okay, it's created. Perfect. Yeah, great. It's created that media bot. And I will show you those policies in 1 second. Okay, let me just go across back to that UI. So if you see these policies, right? So yeah. So this is a graphical visualization of that particular policy that you've created using endpoint selectors and the egress. What I'm trying to say is that I will only allow packets that are headed towards api.github.com. If I try to send something to like a support.github.com, right, those packets should be dropped. That's exactly the same policy I've applied just now. What I will do now is, and let's just go back here to connections. Let's just make this a little
Amit,
bit
a
bigger.
quick question.
Sure.
This tool is a dashboard. It's recommended for monitoring Cilium and its components.
That is true. It's actually not there from a perspective of monitoring Cilium's components, I would say. When you say
Okay.
components, right? Like let's say you're looking at the pod resources and all those things, right? No, I wouldn't say that because then you will be looking at something very different outside of that persona, like a cube cost, right? That's completely different. It's just completely concentrating on what those particular pods are doing, what those resources are doing. Is there a back off pressure happening and whatnot? No. This is from an observability perspective of what and how the apps are behaving. And you want to apply policies, you have processes. We have something called as processes, which is a part of another networking and security observability tool called Tetragon, wherein you can inject, some particular, you want to observe something like somebody does a VIHC password and you want to see that. You can get a graphical view of what is happening inside your pods, who's trying to do what.
All right. So is this available to Grafana as well? Like let's say if you're going with the centralized dashboard using
Oh, for sure.
Prometheus and Grafana.
Absolutely. Absolutely. This is available for Grafana, for Prometheus, even for, what is this? For Azure Sentinel. It's also available, if I'm not wrong, for another offering from Azure. I always forget the name. I'm sorry about that. But it's available all across the platform.
Yeah, thanks.
What I will do now is, like, I think the key thing would be to see something like a drop packet, right? So here, this guy is sending a legitimate packet. This should be allowed. Okay, so this is a 200 OK. Now, if you see this, let's just wait for this couple of seconds. Yeah, so if you see this was allowed. This was allowed. So you have egress forward API github.com. It's done. So immediately the moment I sent for something, right? So it just popped up in this particular view. Now let's do one thing. I will go across and send something for support.github.com and I'll show it to you here. Same from the MediaBot pod. Nothing will happen, but here we should see a drop packet. The verdict should be dropped. Yeah, so you see that? So this guy is trying to send something towards support.github.com and we've just dropped it. Any questions or you would like me to move across? I'm happy to do that.
So Amit, this is Nihali. And so I have to be very honest. I come from a lot of traditional networking, data center type background. Of course, do a lot of Azure work. But could you explain this a little bit of this concept of managing these network policy? How are you just denying and allowing these? How does like I know you applied it, but if you could just shed some light on how does one go about editing these and viewing this policies?
Oh yeah, sure. So let's say you want to create a brand new fresh policy, right? So you can create these policies. So the concept is around how you want to break it. So there are two ways to do it. One is a cluster-wide policy, which is something like a perimeter firewall. You have something called as Cilium Cluster Network Policy, CCNP. So that is like a perimeter firewall. You want to go, you don't want anybody to go across and talk to, let's say, an API server which you are hosting. You don't want people to talk to it. So that's a cluster policy, a cluster-wide policy. Let me actually, since we're speaking, right? So let me just go across and show you that scenario. Would this help?
Yes,
Yeah.
that's just how the way I see it. Yes.
Just give me 1 second. So this is what's happening. So basically, you have your policies, right? So you are able to act on those endpoints. You're looking at endpoints and you're making sure that those endpoints can either talk or they cannot talk using some specific scenarios. If you look at a classical K8s network policy, right? You will be just looking at the concept of namespaces and whatnot. You have something called as an endpoint selector. So you are selecting that endpoint to be a class object or whatever, and then you are denying it, allowing it, or doing whatever you want. Now comes the part, do you want to go across and do it at a layer 3 level? You want to do it at a layer 4? You want to do a combination, or you want to do it at a DNS based? You can attach labels to it saying that, okay, if there is a specific label attached to it coming from X tenant for that particular workload, then send it or deny it. Visible is something which is a perimeter, a cluster-wide policy. You do not want, a cube DNS. You do not want people to go across and send some malicious packets across to your DNS servers and whatnot, reducing that specific overhead and every perspective. You want that to be defined in an area that, it should be defined, constrained in that tenant. That's where you can use a cluster-wide policy.
And that's for inbound and outbound.
Absolutely. You can define like if you see here, right? If you let me just go back to the screen. So you have these directions. So if you let me just make that even more bigger. So this is ingress, this is egress. Left side is ingress, right side is egress. So you can play with it and do whatever you feel like from that perspective.
Got it. Yeah. So the visual is really good. And how does, so this tool is baked into, we need access to the portal, or how does one access this tool that you're using?
Yeah, and since I'm doing that, let me just kill this. If you see here, right? So you have something called as a Hubble Enterprise as well as a Hubble UI. So this comes as a different sort of a Helm packaging wherein this gets exposed, and you can go across and so basically it goes like this. If somebody would want to pick up the enterprise offering from Isovalent, right? So it all depends on what's your use case. Either it is just classical networking wherein you are just looking. Let me break away for 1 second. So one is a user-based interface, and then you have also something like a Hubble relay, wherein you can visualize everything on the command line itself rather than viewing it in the UI. Now, mostly people are more concerned towards looking things in the UI. So that's where this concept comes in the picture. So then you have to go across and, pick up Hubble UI as well as the fact that, how you want to package your particular SKU for it to be rolled out to the customer.
Got it. So where you were doing the policy editing is in the Hubble UI?
That is accurate. So let me just see if it shows. Okay, so it's got nothing to show here right now. Maybe it's yeah, I will just okay. Yeah, that is correct. That was on the Hubble UI, right?
Okay, thank you.
Okay, and with that, I will go across and let me see what I was planning to cover in the slides next. And yeah, so we have some good amount of features that are available from an enterprise perspective. I wanted to talk to you about, let's say you have, so I have something which is, so basically what is happening is that you want to do encryption between two pods. So and these two pods are latched onto two different nodes. So you want to do something like a WireGuard or an IPsec based kind of encryption. So let me just show one thing quickly. Status. Okay. So just for the sake of time, right? So I've actually enabled WireGuard encryption. If you see here, right, encryption WireGuard is enabled. It's enabled. So basically, if there are two pods that are going to be get that will be created on two different nodes. So the traffic will flow via an interface called the Cilium WireGuard 0 interface. If I go back here on this node, right, you see something like this. So this automatically gets created. There is no such, the beauty of the way you are working in either a BYO CNI or an Isovalent Enterprise for sale from the marketplace is that you don't have to go across and pick some specific packages to go across and install these. If these are enabled in your Helm chart, they will be enabled. There is no way you have to do something really out of the box, like be it the case for cluster mesh or service mesh, whatever you want to do. It's just enabled. You just have to go across and make sure how you are envisaging your particular network and how it should be done. I will just create this. So I'll just show you. So this is a client file. So basically this client is, going to do a wget towards the server, which is on a different node. And we see that the packets are over a WireGuard 0 interface. And what I'll do is so let's just quickly see. So if you see here, the client gets created on B, whereas server is right here. That gets created on A. Okay, now I wonder, okay, it's not there. Actually, let's just do this. Let's just kill this and yeah, no, let's pick this up. I wonder if it has spam or not. That's so the server pod is attached to 00B. So what I'm going to show is, I hope TCP dump is there. Okay, great. Just clear this up. TCP dump minus CNI. Cilium underscore WireGuard 0. So if you see, the client was sending pods to the server via a wget it's trying to do. So it's doing it every few seconds. It's actually running in the background. If I were to stop it, right? So let's just look at yeah, if you see here, right? So it's sending those packets and it's receiving those particular responses. We can quickly see the fact, yeah. So it's right here, the communication. So you can see that these packets are going over the WireGuard 0 interface. This is all fully encrypted. That's one. I also wanted to show you guys. So you have this concept, I think, Nihali, you had requested about, something from a service mesh perspective and all that. In the meantime, let's just quickly take a look at those. Okay, great. So if you see, these clusters have been created, one on CNI and one on this. So let me just fetch the context for these. Refresh. I think there was a question from somebody. Did I miss? Okay, no. Source groups. Maybe I have seen our demo. And yeah, where is it? Great. Right here. And let me just what else to do? So if you see, there is this core DNS which is running, and there's no other CNI that's been there. We can go across and install Cilium on top of it, and then it should be. If you just do a kubectl get nodes minus O wide, you'll see that it's in not ready state. Visible is the fact. Let me just take this here a little bit and just fetch the uh, context for this guy. 1 second. It should be IE4C. Yep, IE4C overlay. So this is Isovalent Enterprise for Cilium in overlay mode. Pick this up. And okay. Let me just enlarge this a bit. So if you see here, right, Cilium is running here. You don't have to do anything from that perspective. Your billing operator pod that's running. So you don't not have to go across and do any kind of an intervention to bring up that particular cluster. It's a similar behavior you use with AZCLI, with ARM, with Bicep, or even from the portal. If you were to see the nodes, all of those nodes should be around as well, and there should not be. Yeah. if I were to just do get NNC minus A. So this is, so if you see, this is with overlay mode, right? So it's allocated me IPs in a chunk of /256s. Had that means the pod subnet mode, the NC mode would have been dynamic, and the allocated IPs would have been like, I think starts up with 512. So one just last thing I wanted to show in this particular scenario, that like I said, Cilium gets installed as an extension on top of that particular AKS cluster. So this is running as an extension. I will
So
now,
is
yeah.
ingress, if is ingress also an add-on that gets installed, or is that a separate step?
That's a great question. No, you don't have to do, like I said, you don't have to do anything from that perspective as well for Ingress Nihali. Let me just stop. And I just want to show you that. Just 1 second. Yeah, let's go here. So let me just show. So basically, what happens is we have a Ingress class name called as Cilium. So what I'm going to do now is that it's going to create a load balancer service, and that load balancer service, what I'm requesting is using an annotation that the load balancer IP should be internal. I can take external IP as well, but just from a use case perspective, right? I wanted to show that how, and I have a chunk of annotations that I've tested that work fine, right? So what we are going to do is that I will create this particular ingress. The IP from the load balancer will get copied to the ingress, and we will send traffic and see how it works. In the meantime, I want to show one more thing. So I've already created a demo app. The demo app basically has all these parts. So you see reviews, ratings, details. If you would have seen this, right? Let me just open this again. So that's exactly what it's doing. It's going to call the backend service and get that particular response for me. You've got to apply my step ingress.
And Amit, this extension, we cannot use that one on an existing AKS cluster. If we need the Cilium, then we need to create a brand new AKS cluster, right?
That's an, so I've actually covered so many scenarios, right? And Soumyan, can you just give me 1 minute and I'll come back to your question? I just wanted to finish off with this ingress part because I want to address that, because that's a very important question that even our customers ask. So if you see the service, yeah, sure, I'll get back to you. So if you see that, it's now right now in pending step because it's requesting an internal IP from the MC underscore subnet that that is there. So it should probably give something. It's still pending. Still pending. That is odd. Should have got it by now.
I've seen it does take a while. This is the Azure internal load balancer that you're
That's
waiting on,
correct.
right?
Yeah. Oh, okay, great. It's got it, right?
Yeah.
So 10.2.2.4. So if you see, right, let me actually walk you through there as well. Resource groups, I can't remember all that. It's called BYOCNI. Yeah, BYOCNI. No, my bad. Let's just go back. BYOCNI should be in BYOCNI. Yeah, this one, correct. So if you see here, there should be an AKS VNet. There should be settings, subnets. So it's requesting this IP from this app testing pool actually, and then they should be connected. And if you see here, right, so this is exactly what's gotten created 10.2.2.4.0.7. If I go back here, right, so this is what it is. If I see my ingress now, right, it's copied that address across to my ingress as well, which is 10.2.2.4.0.7. So I didn't have to enable anything. In the nick of time, right, let's just do one thing. Let's just copy that. And we'll see a response if it comes or not. Oops, what happened here? Oh yeah, my bad. I was in the wrong this thing. Yeah, I should be here. Not in that. And the load balancer IP is 10.224.0.7. You see, it sends back a response that, HTTP 200 OK. And this is just the app, which is the way it's been designed, and it responds to that.
Got it. Yeah.
So this is about Ingress. I actually had one more thing to talk about, something we've done for DuStack, but I want to address Soumyan's question first, which is actually a very important question. Before that, Soumyan, sorry for me to sort of digress. There is another very important thing, or sort of a feature perspective that is there on offer from the perspective of how people would actually end up using the Isovalent offering is something called as cluster mesh. So basically in a multi-cloud connectivity model, right, wherein you have, let's say, AKS clusters in different regions, you would do peering and the fact that you have workloads behind them and whatnot. So you have something called as a cluster mesh. AKS, I think, would be a little bit different because you would end up using even like a PLS, private link service and whatnot. But if you want to do something like a cluster mesh between a a private cloud, and want to bring that traffic across to your, let's say, an AKS cluster, you want to mesh these together. So you have something called as a cluster mesh. You can go across and, make a cluster mesh. You can extend that to any other cloud as well, to AWS, to GKE, Rancher, whatever you feel like. And then you can have services that can, talk to each other. There could be scenarios where you will end up with an overlapping IP address schema as well. So that itself is also covered there. We have support for non-overlapping as well as for overlapping CIDRs as well, using something called as a phantom service. So basically it's a ghost service. So all of that is possible. And since you talked about that topic, right, I wanted to actually bring up this flow chart that it's something I had created, Somin, which you wanted to understand, right? So if you want to move across to the enterprise side of things, right? So traditionally what you have is, when we started off, right, long back. So when the concept of the CNI from Cilium with Azure started, right, you had two modes called as bring your own CNI. Let me make that even bigger. And Azure CNI, which is the legacy IPAM, which is Azure CNI V1, version 1. So you can directly upgrade to something we call as Isovalent Enterprise Cilium, which is not through the marketplace, by the way, which is like, directly contacting us and whatnot. Then comes the part that you want to, do something like a legacy IPAM, but you want to move to Azure CNI powered by Cilium and eventually to Isovalent Enterprise or Cilium in the marketplace. You can do that as well, but it's like a two-step upgrade. You have to go to CNI overlay, then to this, and then you have to eventually come to us. Sadly, with bring your own CNI, if you want to come to this and then to this, that's not possible. That's a support which is denied by Microsoft itself. You're most likely going to end up in recreating that cluster. But for all other options, let's say you have Azure CNI Dynamic IP, KubeNet, Azure CNI V1, Azure CNI Overlay, Azure CNI powered by Cilium, all that is possible. It's fairly good. In fact, this is like a one-click upgrade. Just go click a click and you are boom, you are ready to go. Does that answer your question, Samin, or you want me to?
No, all good. Thanks, Amit. Yep.
And that was one. And lastly, I think that was something I had to show. Okay. Yeah, we can quickly just switch contacts. So we've done work on this, which is, sort of the support that the AKS team had done for DuStack. We've leveraged on that. And let me just. So this is a cluster which is running in DuStack. So I have nodes. Let me actually show it like this. But the API call from Azure actually just returns the V4 internal IP. So that's why I'm grepping on the internal IP to show that it has actually both of them. If I were to see the status, right? So I've installed Cilium in an IP6 enabled mode. If you see this, right? So you have IP6 interfaces here as well, and it's allocated IPs from FD00 as well. This is on bring your own CNI. I can actually do this from Isovalent Enterprise from Cilium as well. let's just see if I have pods running here. Yeah, great. So basically I've just created 2 pods. So if you were to see here, right? So pod worker, this is the pod worker, right? So the one IP is FD003D8 and the other, we can grep for that as well. That should not be a problem. It's actually visible, but just to right there. Okay. Showing 0. So it's 1003. So what we can do is we can send some traffic from pod worker to pod 1 worker 1. Let me clear this up a little bit. I'll set this context, and from pod 1 worker 1, I will send traffic to pod worker. So if you see here, right? So it's sending traffic and it's getting a reply back. Similarly, if I were to, go, so what I've done is, so let me just show this service, edit service equals. So it's a plain dual stack service with IPv6 4 type. What it's doing is it's set on type as cluster IP. So this is, if let me just describe this service. So this is what it's doing. If I just want to send some quad A queries to it, DNS queries, that should just return something. Yeah, so it returns this particular IP, FD95. So if you see here, right, it matches to this. And if I were to send it from the other guy, I think I'm going to receive a similar sort of a response from there as well. Yeah. So like I said, from a feature perspective, you don't have to go across and, pick it up via packages or whatnot. It's just simply available via Helm or your CNAP bundle and you're good to go.
Excellent. Awesome demo. Thank you for showing us this.
Sure.
Yeah.
And one last thing that I wanted to share, there is I can share this with Nihali. She can send it across to you. Like I said, this is what I was covering here, the Terraform. All of that is here. You guys are more than happy to try it, or I go across and solve issues as well that people report, as well as something that I've started for Bicep as well. So please feel free to take a look. If it helps, nothing like it.
Yeah, this is great, Amit. Thank you so much for sharing.
Sure.
Yes, excellent. Amit, thank you so much again for joining us today. It was great learning for the team.
Pleasure. Thank you so much.
Excellent.
And if you can share that PDF format of this deck, that would be very helpful, Amit. This has lots of information, which is very helpful to refer.
Sure, Soman. Definitely.
Yep. Thank you. Thank you, Nihali.
Excellent.